Continuing with our discovery about slopes, we are going to graph two more points. This time our points are 1, 3, and 4, 3. So to graph 1, 3, go to your origin, over 1, up 3. To graph 4, 3, origin again, positive 4, so I'm going to the right 4, and I'm going to go up 3. All right, let's go ahead and graph our slope here. Our slope is going to be when we connect the lines, or the points. There is our graph. Now, again, remember when we are doing slopes of lines, we're talking about the rise over the run. And for this particular one, the rise is going to be this line here. And the run is going to be, whoa, sorry about that. The run is going to be this way. Now you'll notice this time we do not make the slope of the line, the blue line, does not make this into a triangle. We do not have a triangle here. If we start at one of the points, I'll start it up here instead. We cannot make a triangle. The blue line does not cause a triangle. That's because this slope, if you remember our little runners, this slope, if I was reading left to right, I don't have a slope. I'm walking nice and flat. So there is zero slope. If I follow my rules about how I figure this, the difference of the y's again, and I said usually we go to the one that is higher, but these are at the same place, so it's not going to matter which set I start with. I'm going to start with this one, 3 minus 3, that's what you see right here, and then I'm going to do 4 minus 1. By doing it in that order, I did not need to worry about any negatives. 3 minus 3 is 0. 4 minus 1 is 3. We know that we cannot have a fraction with 0 pieces. If we had a pie that had 3 pieces and you ate 0 of it, you didn't eat it at all, so that's 0. So this would be a slope that has a slope of 0. Okay, nothing. Moving on to the next one, we have 2 coordinate points again. We're going to graph 2, 3. Came over 2, went up 3. I'm going to graph 2, negative 1. Okay, I'm going to go from one of my points and look at the rise. I'll just park it here. But I went to the other one too. And then we're going to do our run. I did it again. That run doesn't like to come up there. Except I'm not running from either one of those. I will not connect if I run. So if I just connected my lines, my points, I said that again. My points are telling me the same thing as my rise was. So now I have, again, looking at the difference between my y's, I'm going to do I have a negative 3 there. No, I have a negative 3 down in my equation here, and that would be wrong. There we go. So if I do a 3 minus a negative 1, this y, minus this y, minus a negative, add the opposite, so that's 3 plus 1, gives me my 4. Now my 0's in the wrong place for my fraction here. And then if I do my the difference between the y's, 2 minus 2, that's going to give me 0. When we are finding the differences, always make sure you're using the points in the same order. So if you start with this y, you need to start with this x. Now that's 4 over 0. In fraction terms, that would mean we shaded in 4 pieces of absolutely nothing. That can't be done. There's nothing to shade into. So this slope here is an undefined slope. There is no such thing. We would just fall off of the mountain or zoom up into the sky. All right, the last terms that we will talk about that also have to do with slope are going to talk about rate of change. And this you deal with a lot in science class. We're going to go back to the wake order that we talked about at the beginning with the ramp. And this time we're going to get some times. The wakeboarder was able to, he measured how far he went at certain times. Okay, in 2 seconds, he traveled 52 feet. But by 7 seconds, he was able to travel a total of 182 feet. So the slope of the line gives the wakeboarder's speed, which is the rate of change in distance traveled with respect to time. So we need to find the wakeboarder's speed. So first of all, let's figure out how we're going to interpret slope as a rate of change. I'm going to change my information here into coordinate points. So I'm going to do time first, okay, 2 seconds. I'm going to let my time be my x. And then how far I travel is going to be my y. Here again is time, and here again is travel. So when I do that, I end up with 2 coordinate points, 252 and 782. Now, just doing the math part of this, I can go ahead and say, again, I want to find the difference of my y coordinates, difference of my x coordinates. Now at this point, I don't know what it looks like on a graph yet, so I'm going to again make it a little easier on myself and try not to get any negative numbers. I do much better when I do not have negatives. So I'm going to go to the larger y here, and again, if I start at this one, I need to make sure that I'm going to start at this one. This is my starting point. So if I do 182, go to this set of coordinate points and find the y, I get 52. 182 minus 52. If I start here, I'm going to get 7 seconds because x was my time, and I'm going to subtract 5 seconds. 7 minus 2. When I do the math there, I'll get 130 feet, and that'll be in 5 seconds. That means that the wakeboarder was traveling at 26 feet per second. 26 feet per second. Now to graph this one would be a little bit more difficult because our coordinate points would have to fit on a very large graph because we have 182 here and we will go down to the smallest number is 2. So just figuring out the story problem, I could do it just by putting those into coordinate points and then finding the difference between them. If he's traveling, you know that it's going to be a positive change. He's not traveling, it didn't say he was traveling backwards, so we're going to have a positive change here, or a positive slope. So that's how you could use it with rate of change when you're just given a story problem. And that finishes off 8.4 with slope of a line.